Listen to that sound. That is not a sound effect. That is the actual radio emission of Jupiter, a planet so magnetically violent it screams across the solar system. And caught inside that scream, trapped in orbit so close it cannot escape, is the most tortured world we have ever found. In 1979, a scientist sat down and did the math. He ran the numbers on what Jupiter's gravity should be doing to this small nearby moon. He calculated the friction, he estimated the heat, and what he found was so extreme, so implausible, that the paper almost didn't get published. 3 days after it was submitted, Voyager 1 flew past the moon. What the cameras found confirmed every single number in that paper and shook planetary science to its core. They had predicted a hell, and they had found exactly that. This is Io, and once you understand what is actually happening here, you will never look at the night sky the same way again. Act 1. The prediction. Act 1. Zero. Before Voyager arrived, astronomers assumed Io was a dead, frozen rock. It was small. It was far from the sun. There was no obvious reason for it to be geologically active. But 3 scientists, Peale, Casson, and Reynolds, had done something unusual. They sat down and calculated what Jupiter's gravity should be doing to this moon in extraordinary detail. They factored in the gravitational pull from 2 neighboring moons, Europa and Ganymede, whose orbits are in a precise timing relationship with Io's. They found that this resonance should be generating an enormous amount of tidal friction inside the moon, enough, they calculated, to melt its interior and drive active volcanism. They published the paper. Days later, Voyager 1's cameras returned images of enormous volcanic plumes erupting from Io's surface. Active volcanoes. On another world. For the first time in history, exactly where the math said they should be. Science predicted reality in real time. The paper and the proof arrived almost simultaneously, but what Voyager was actually looking at went far beyond anything those early calculations captured. Because Io is not just volcanically active, it is the most geologically violent object in the entire solar system. And the reasons why are stranger and more extreme than anyone expected. Act 2. The machine that never stops. 2:30. Io orbits Jupiter at about 422 iosolar kilometers. That is extremely close, roughly the same distance as our own moon from Earth. But Jupiter is over 300 times the volume of our planet. The gravitational forces involved are on a completely different scale. As Io moves along its orbit, it is caught in a permanent 3-way tug-of-war. Jupiter pulls at it from one side. Europa and Ganymede pull from different angles as they pass. Because of the precise timing of their orbits, this pulling never cancels out. It never lets Io settle into a perfect circle. Its orbit remains very slightly oval-shaped, which changes everything. As Io swings closer to Jupiter and then farther away, the gravitational grip on it fluctuates. And because the pull grips the near side harder than the far side, the entire moon flexes. It stretches. It squeezes. Io's solid rocky surface rises and falls by up to 100 meters with every single orbit. Think about that. The ground beneath your feet, rock and stone, heaving up and down by the length of a football field. Not slowly, constantly. Every 42 hours, Io completes one orbit, and the cycle repeats. That flexing generates friction. Friction generates heat. So much heat that it melts the interior, and the molten rock pushes upward through any crack it can find, erupting onto the surface in an endless cycle that never stops, because the gravitational machine driving it never stops. The Io is not volcanic because it is young. It is volcanic because it is trapped. It cannot escape Jupiter's grip. It cannot change its orbit. It is being squeezed to death, and it has been for billions of years. Act 3. What we got wrong. 4:50. For decades after Voyager's discovery, scientists built a theory about what was happening inside Io. The evidence seemed clear. Io's magnetic field, detected by the Galileo spacecraft in the 1990s, appeared to come from an enormous electrically conductive fluid inside the moon. Scientists analyzed the data for years. By 2011, the scientific consensus was firm. Io had a global magma ocean buried roughly 50 kilometers beneath its crust. Not a few pockets of lava. A planet-wide underground sea of liquid rock, nearly 5 times deeper than the Pacific Ocean at its deepest point. It was a remarkable idea. The most volcanically active body in the solar system, hiding an ocean of magma beneath its surface, feeding hundreds of volcanoes simultaneously from a single connected source. There was just one problem. It wasn't true. In 2024, an international team published new research in Nature. Using the most recent Juno flyby data, the closest observations of Io ever obtained, they found no evidence of a global magma ocean. The magnetic signal that everyone had interpreted as a subsurface ocean had a different explanation entirely. The interior of Io is not a single connected sea of liquid rock. It is a patchwork, isolated pockets, localized regions, something far more fragmented and strange. The most volcanic world in the solar system, studied for 45 years, and we still do not know what its interior actually looks like. That uncertainty alone should tell you something about how extreme this place is. Act 4. The surface of hell. 6. Ajinu. Now imagine descending toward Io's surface. The first thing you notice is the color. It looks nothing like what you expect. No gray rock, no red desert. Io is painted in yellows, whites, deep reds, and patches of absolute black. Sulfur in its many forms, coated across everything like a toxic canvas. From a distance, it looks almost beautiful. A painted world. But the instruments would be screaming almost immediately. The radiation here is 600 rem per day. A lethal dose for a human is around 600 rem. Io's surface delivers that in about 4 hours. No spacecraft has ever landed here. No mission has ever attempted it. The radiation makes Io's surface one of the most hostile environments in the solar system, and it is not natural background radiation from space. It is Jupiter. The planet's magnetosphere captures the ions blasted off Io by its own volcanoes, accelerates them, and bombards Io's surface with its own material turned into a weapon. And then you see the volcanoes, over 400 active volcanoes, but not cone-shaped peaks. Most are broad, flat depressions, calderas called paterae, some stretching hundreds of kilometers wide. They don't build up. They pour outward, flooding plains with rivers of molten silicate rock. In November 2025, researchers published findings from Juno's 2024 flybys revealing something extraordinary. Io may be emitting hundreds of times more heat from its surface than scientists had previously estimated. The previous numbers were not based on bad data. They were based on a misinterpretation of how to read the infrared instruments. When corrected, the heat output was staggering, and roughly half of all that heat comes from just 17 of Io's 266 known volcanic sources, not spread evenly across the surface, concentrated, focused, like a world with pressure points. Juno flew close and found something that broke the record books entirely. Near Io's south pole, it detected a single volcanic hotspot, larger than Earth's Lake Superior, producing 6 times the total energy output of every power plant on Earth combined. The heat was so intense, it completely saturated Juno's infrared detector. The instrument designed to survive Jupiter's environment could not handle what it found on the moon. Act 5. Mountains that shouldn't exist. 8:30. Here is the thing almost nobody knows about Io. Its tallest mountains have absolutely nothing to do with its volcanoes. Io's highest peak, Bosal Montes, rises to 17,500 meters, nearly twice the height of Everest, and it stands almost completely alone, jutting from the flat volcanic plains with no surrounding range, no foothills, no geological context that makes intuitive sense. You would expect the most volcanically active world in the solar system to build its mountains through volcanic eruption. That is not what happens here. Io's mountains are tectonic, and the mechanism behind them is one of the most counterintuitive things in planetary science. Because Io's volcanoes are constantly erupting, they are constantly burying the surface. Fresh lava pours out, cools, gets buried by the next eruption. The older rock sinks inward under the weight of everything piling up above it. This creates an enormous horizontal pressure at the base of the crust, a squeezing force building up with nowhere to go except upward. Eventually, it finds a fracture, and it punches a massive block of ancient crust straight up through the surface like a trapdoor slamming open from below. Not a volcano pushing material up. A compression wave lifting an entire chunk of existing crust into the air. The mountains on Io are built by the volcanoes. The constant burial is what creates the compressive force. The very thing covering the surface is what builds the highest peaks. They are not opposites, they are the same machine. And there is one more implication that scientists find genuinely haunting. This mountain building process does not exist anywhere else in the solar system today. But it may have existed once before. When Earth was very young and still covered by a shallow primordial ocean, the same mechanism, compression driving crustal blocks up through the seafloor, may have created the first dry land that ever appeared above the water. The first mountains any life on Earth would ever have seen might have looked exactly like what we are now watching happen on Io, a glimpse of our own ancient past playing out on a burning moon of Jupiter. Agt 6, the electric moon, 10:45. There is something else happening on Io that goes almost entirely unmentioned in popular science. As Io moves through Jupiter's immense magnetic field, it behaves like a wire cutting through a magnetic field in a physics experiment. It generates electricity, enormous amounts of it. Io develops 400 volts across its entire diameter. It produces an electric current of 3 million amperes, flowing not just through the moon, but along Jupiter's magnetic field lines all the way to the planet's upper atmosphere, 422 kilometers away. This is called the Io flux tube. It is one of the most powerful electrical circuits in the solar system, and it connects a volcanic moon to a gas giant like a wire connecting two terminals of a battery. That current arrives at Jupiter and crashes into its atmosphere, producing auroras. Jupiter has the most powerful auroras in the solar system. And most people assume, like Earth's northern lights, that they are powered by the solar wind. They are not. Jupiter's main auroral oval is primarily driven by Io. The volcanic eruptions on this small moon are painting light across a gas giant across hundreds of thousands of kilometers of space. And there is still more happening. The material blasted off Io's surface, sulfur, oxygen, sodium, gets captured by Jupiter's magnetosphere and accelerated into a ring of plasma that completely surrounds Io's orbit. This glowing donut of ionized gas is called the Io plasma torus. It blazes in the ultraviolet, invisible to the naked eye, but one of the most energetic structures in the entire Jupiter system. And every single second, Jupiter's magnetic field strips roughly 1 ton of material from Io and feeds it into that ring. 1 ton, every second, without pause. For billions of years, Io is not just being squeezed, it is being consumed. Act 7, the bigger picture. 12:30. Step back for a moment and look at what Io actually is. It is a moon the same size as ours. By every rule we know about planetary bodies, it should be cold and silent. Instead, it is a world being ripped apart in real time, its ground heaving by 100 meters every 42 hours, its surface constantly melting and reforming, its mountains building themselves through a mechanism unique in the solar system. Its material being stripped away and fed into a glowing ring of plasma around the largest planet in the solar system. And here is the most important thing to understand about Io. It will not stop. The gravitational resonance between Io, Europa, and Ganymede is stable. It is not winding down. It is not fading. As long as Jupiter exists, As long as those 3 moons maintain their orbital timing, Io will continue to be squeezed. It will continue to erupt. It will continue to lose material into that plasma ring. It will continue to power Jupiter's auroras from hundreds of thousands of kilometers away. We found a world that should be dead, and instead found the most geologically alive place in the solar system. We studied it for 45 years, built a confident theory about its interior, and then had to throw that theory away in 2024 at it and keep getting surprised. The paper predicting Io's volcanism was published days before Voyager confirmed it. Since then, nearly every close encounter with this moon has overturned something we were certain about. That might be the most honest thing we can say about Io. Not that we understand it, but that every time we look more closely, it turns out to be stranger, more violent, and more remarkable than we thought. Look up at Jupiter on a clear night, find that bright point of light, and know that trapped in orbit around it, something the size of our moon is actively tearing itself apart, and has been for longer than complex life has existed on Earth. It does not need our attention to keep burning. It just burns.